Chapter 10, Trigonometric Identities and Equation. Um, First of all, we didn't discuss actually in the chapter 9 because we didn't get a chance. What is trigonometry? What is trigo- what is trigonometry? Trigonometry is a relationship between side length and angle of a triangle. Trigonometry is a relationship between side length and angle of triangles. So it is a relationship between what? Side length and angle of what? Triangle. Triangle, usually we will specially discuss the right angle triangle. It's a relationship between side length. So those are the side length and angle. So assume that if you come and stand up here, I will take this alpha, then this is angle we measure with degrees. And if I write ABC, this one, so BC is a length, AC is a length, AB is a length. Now when I write sine alpha mean opposite divided by adjacent, or BC divided by AB, so this is a ratio of a length, ratio of a two lengths, and this is um, alpha angle. So it is a relation with the angle and the side length. So basically the behavior of these two together, the angle and this length or the ratio, uh, we learn in as trigonometry. So now this is alpha. Let's say now, okay, I'll take this is 30 now. So then what will happen when this is increasing? What kind of variations, how the length and the angle, when the angle is increasing, what will happen to this ratio? And it is in a different format. For example, if we bring this triangle into a xy plane, what will happen? So this kind of study we are doing in this chapter. For example, this is a right angle triangle, and this angle is 30, and 30 with sine ratio. For 30, sine ratio mean opposite divided by hypotenuse, BC divided by AB, and cos 30 mean AC divided by AB, tan 30 mean BC divided by AC. Now this 30, so I will keep the AB length as it is, and I will move this one. This B I'll bring to here. I'll say B dash. Now this angle become 45 total. Now what you can tell about, now you can see this BC length is getting bigger. So I'll put C dash. When the angle is increasing, this BC length, the opposite length, is now become bigger, and this AC length, now it is AC dash. becoming smaller. So then, if it is sine 45, it is going to be BB dash over uh, AB dash. Cos 45 mean AC dash over uh, AB dash. Tan 45 mean um, B dash C dash over AC dash. Actually, I said that AB length is, I'm not going to move, it's the same length. Uh, AB equal A AB dash. Now you can see that AB and AB dash same. So if I write this is A, this is also A. Now you can see that in this sign BC, this is small. The length is very small. But uh, B dash C dash, B dash C dash, this side. Now it is bigger than BC. Now what you can tell, when the angle is increasing, what will happen to this value? This value, since A is same, the value is increasing. What will happen to cos when the angle is increasing? When the angle is increasing, can you see that this length becomes smaller? It means cos value is decreasing. So accordingly, we can get an idea about tan value. Right? So now we did the research. We see that what is happening. Right? In this trigonometry, what in this chapter, we'll bring this one, this right angle triangle. We place this right angle triangle. We place on xy plane. So this is A. This is B, and this is C. Now this ABC triangle, I took it to the xy plane, and instead of I'm moving along the xy plane, and I'm trying to build up a relationship, uh, any special things, any relationship. So even now this is 30. Now can you see that I kept this AB or hypotenuse is fixed here. Sorry, uh, that's this point is fixed, and I move this point B to B dash. Likewise, this hypotenuse, I'll fix this point and I'll move this point. So if we have 2 points and this is fixed and this is mobile point, but this point is mobile, keeping the same distance, then what is the path of that? It is a circle, right? But in this trigonometry, we are not going to learn about circles. Just to get an idea what will happen if I move this keeping AB distance same, and with fix A, if I move B, what kind of path we are going to get? It's look like circle. It does not look like it has exactly circle. Now this is 45. This is B dash and C dash. So we discuss when the angle is getting bigger, what will happen? This BC, the sine ratio is increasing. Cos ratio is decreasing. I didn't take tan ratio. What is happening? But tan ratio should be increase. Right? So likewise, I'll bring it here. Another one. Can you see now? This length is increasing. It means sine ratio is increasing. This length is decreasing. C double dash. It means cos ratio is increasing. So uh, this is hypotenuse. Or also you can refer as this is what? Radius. Because this is a circle finally. It's going along the circle. Hypotenuse or circle. But it doesn't, but we should not mix that. Still this is hypotenuse. But we can name this as radius. Now um, this height is positive because this is xy axis. This height is positive. This length also positive. Radius is positive always. Right? Now, okay, we'll move this one. We are increasing this angle now. 30, 45, then 85, right? And if I bring much closer, something like this, and in one time it will overlap. When I move this one, this will overlap. What is the meaning of that? When it's overlap, this AB and BC length become same and AC becomes 0. So when it is overlap, this angle is 90. What you can tell about sine 90? Sine 90 mean BC divided by AC, right? But this at sine 90, this is overlap. It means uh, BC and AB is going to be same. BC and AC going to be same. It means BC over BC. Or you can write AC over AC. Or they become both radius. If I take radius, okay, I'll take this is R radius. Comfortable. So R over R. Answer is 90. 1. So what will happen? Sine 90. Sine 90 is 1. If I write here, so sine 90 is 1 now. What will happen to cos 90? When this is becomes C and getting smaller, when it's overlap, this AC becomes 0. Now 0 over hypotenuse AB or R. It means 0. Cos 90 is 0 then. 0 over R is 0. What is happen? Tan 90. Tan 90 means this length R divided by adjacent AC. Now AC becomes 0. Anything divided by 0, this is infinity. So I'm moving further. So BB double dash, or this is C triple dash, B triple dash. I'll put this is B4 and this is C4. When it is 90, this angle is 90, as I said, this BC and this AC. We write so sin alpha equal BC divided by AB. BC divided by AB. Cos alpha equal can't see sin alpha equal BC. I'll take this is alpha. BC divided by AB hypotenuse. Cos alpha equal what is cos alpha? AC divided by this distance and AB. Tan alpha equal BC divided by AC. I just write. Now what we are doing? We are doing a research now. We are expanding this angle 30, 45, 85. Likewise, when it is 90, we found out the values as well. Now we will go further. So B4 I'll bring to here. So I'll bring this angle up to here. Now it is angle become obtuse. So B1, B2, B3, B4. This is B5. And this is C5. Now you can see that this BC is now B5, C5 here. Now I am expanding more. Now this is B6, C6. Now just after 90, what you can see about this height, opposite. So opposite up to here increase. Now this opposite is getting decrease. It means 90 to 180, what will happen? Sine ratio getting smaller. And what is happening now? Cos, this length. Up to here when it's come, this length become smaller. Now this length become bigger. I didn't discuss the symbols, just the size I am talking at present. Now I'll expand a bit more. Now this is B7, and this is C7. Right? So what will happen? This one, okay, this is a very close one. Now you can see that this length is very small. This one is now getting bigger, almost nearly close to radius now. And the time will come, this is overlap. So that angle is 180. Now sine 180. Sine means this height divided by this radius. Now when it is overlap, this height is almost 0. This height is become 0 when it's here. So then that is 0. And radius is stay the same. Radius. AB. Still AB. So I am turning, rotating hypotenuse. So since it is going along a circle, we can name this hypotenuse as a radius as well. But we are not learning about radius. We are still learning about the angle, relationship with angle, uh, and the length of the uh, triangle. Now, this length becomes 0 and this is hypotenuse r. So sine 180 is 0. Now what will happen cos 180? Cos 180 means, how do you, from here, what is cos? Cos means this distance divided by this distance. Now when it's come to 180, so AC, this length, and AB overlap. Hence, so it is AC over AB mean what? R over R in other way. Radius over radius. It is 1. So cos 180 is 1. Now what is tan 180? Tan 180 mean opposite divided by adjacent. Now opposite also is almost 0. Here there is opposite. Now when it's come to here, it is opposite almost 0. Right? Adjacent is there, 0 over r, or the hypotenuse. So that is going to be 0. Now you know two things. What is sine 45? Sorry, sine 90. Sine 90 is 1. Cos 90 is 0. Tan 90 is infinity. Now, before I go this way, I'll consider again this triangle ABC. So this is alpha. Okay, let's say 30 now again. 30. I'll make it to 25 now. Right, so then B1, this is B, this is B minus 1, C minus 1, or any other symbol. Right, what you can see now, when I am reducing this angle, this height is getting smaller. It means sine ratio is getting, because this height mean what? This height is related to sine. So this BC, or the B dash, is B minus C minus value. Oh, so BC value getting smaller. This is C. This BC value getting smaller. BC mean opposite. Opposite getting smaller mean opposite is with the sine ratio, that sine value is getting smaller. But what will happen cos? This cos value is getting is increasing, because can you see this length is increasing. Now when you look at this one is more less than uh, less than this length, it means it is increasing. Now I'll do one more, very closer to radius now. Now again opposite is very small, and a time will come this is overlap. When it is overlap, what is the angle? Angle is 0. Then angle is 0. What will happen to sine ratio? Because now there is no opposite exist. Because that this height becomes smaller, this height is smaller, 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 and now it is 0. That opposite is 0 now. Then hypotenuse is still r. Sine 0 is 0 over r is 0. Now what will happen cos 0? Cos 0 become adjacent over radius, r over 1. Tan 0 is sine 0 over cos 0. 0 over 1 is 0. Tan 0 is 0. Now we consider this is sizes. Now we want to look at the symbol as well. Right? Now, when you look at this triangle, this height is positive. This height is positive. this length is positive, because we know that in a xy axis this is positive x, this is positive y. So when you coordinate positive positive, what is this side? X value is negative, y value is positive. In this one, x value is negative and y value also negative. In here, x value is positive, y value is negative, right? So likewise, we consider only the sides here. Now we want to give this value to a sign. Now, okay, we'll come to this one first, sine 0. Okay, we'll go to this triangle first. You can see that this height is y-axis, right? This is positive value, 1. This is negative side. So this is positive. This height is negative. Radius is always positive. So then when you consider sine ratio here, so okay, this is 30 now, or sine alpha. Let's stay with alpha. This is positive and AB also positive. Cos alpha. This length is positive and this radius is positive. Radius is always positive. And tan. This height also positive. This length also positive. Okay. If it is here, what will happen when it is 90? When it's 90, this is positive. Both the C value becomes 0, still positive. Right? And this hypotenuse overlap on this one, still positive. So sine 90, what will happen now? This is positive, and answer is positive. This is positive, and answer is positive. And this one, tan 90. See, I will rewrite. Sine 90 means opposite divided by hypotenuse, both same and both positive, positive r and positive r, so positive one answer. Cos 90 is 0 positive and this is r, so that is 0. Tan 90 is now opposite become r, that is plus r, and AC becomes 0 because tan means BC divided by AC. AC becomes 0, so that is positive. When you look at 0 angle, for 0 angle all line positive. So this is also positive because positive, 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 and positive, positive. Right. This is issue now. Let's look at sine 180. Right. When it comes to sine 180, what is this height? Right. This height become 0. And hypotenuse is as it is, or radius. That is always positive. So 0 over r means 0, that is positive. Now cos 180. Now from here to here, if you look at this radius is positive, or this adjacent basically, AC positive. But if you look at A to this one, it is in negative side, A to C5 or A to C6. This adjacent, now instead of AC, now AC5, AC6, AC, they all are negative. Then this adjacent become negative. Adjacent become negative. AC divided by hypotenuse. Cos mean adjacent divided by hypotenuse. This adjacent is negative in here, right? Hypotenuse, that's why I put negative. Hypotenuse always positive. So then negative divided by positive, answer is negative. So tan 180 0 over 0. Tan means sine over uh, sine, no, sorry, opposite over adjacent. Opposite is opposite becomes 0 in here. I mean angle is 180. That is 0. And adjacent is minus r. But 0 divided by minus r is answer is 0. In a summary, if you take a circle like this, right? When you get this one, A, B, C, when you consider this is positive and this is positive, radius always positive. But when it's come to here, right, this is above the y-axis. It means this is positive again. But this is minus x value. So this is negative. Right? So this is positive and positive. This is positive and this length is negative. This direction. Right? And if when it's come to this side, something like this. Now this positive become negative. This y value also, the hypotenuse also, sorry, opposite also become negative. Okay? This value here, positive, positive. Now it's become negative. And when it's come to here, again this value is what? Negative. Same as when you look at this adjacent. Here it is positive. When it's come to here, negative. And this one also negative. But when consider this one again, it is positive. That's all you need to know. If I explain one more time on this one. So you can see this triangle, this height, right? This height is positive. The same height when it is the opposite is positive. But when it's come to this area, it is become negative. But then it come to this area, still it is negative. Now we consider this adjacent. It is along the positive x-axis, positive, right? When you consider this one, this is negative. When you consider this triangle, still it is negative. But when you consider this triangle, it is still again back to positive. Now what we are doing? We draw a triangle. We took a right triangle and we draw on this one on the xy plane, and I fix this point and I move this other point and see what is happening. Right? Then we check the sizes as well as the symbol. Now we can look at the overall picture, size and symbol. When you draw a sine graph, right, you know that this is 90, this is 180, this is 0, right? And sine 0 is 0. Sine 90 is 1. From the graph also you can establish, you can verify that. So then When it's come to here, I am expecting minus 1. Right? When I expand this one, I am expecting for sine behavior. Right? In here, sine, right? When at angle is 0, sine value is 0. So when it's come to 182.70, I am expecting minus 1. We'll see when it's come to here. So now we'll start from here. I'll bring the expansion up to here. Now you can see this is the triangle. If I bring further, now can you see this? Observe this opposite. Opposite here increasing and then decreasing and become 0, and then again what is happening? Opposite is increasing and adjacent. Adjacent is decreasing, then again increasing from here to here, then from here to here again decreasing. Right? I'm expanding this angle now. And we'll look at when this is closer one. Right? You can see this opposite and this radius almost is going to be same. Right? Opposite and radius. It's going to be this kind of position but in a negative side. Then if it is overlap, so this angle is going to be 270. So sine 270 mean sine mean opposite divided by adjacent. So opposite is now almost same as R. But in this side R, positive or negative? This value. It is negative because this is positive. Right? This side is negative. So that is negative R. And hypotenuse. Hypotenuse always R. Always positive, not R. And hypotenuse R because it is radius. And then this is R to R cancel out. Answer is minus 1. Sine 270 is minus. If I explain again this, what is this R and this R? This is sine. Sine ratio mean opposite divided by hypotenuse. Hypotenuse is always R. Can you see that one? And opposite. So opposite is this one. So you can see opposite is becoming bigger. And when it is 90, opposite and the hypotenuse is same length. So what is this length is R, and then opposite again becomes smaller, and when it's come to opposite is 0. Again it is increasing, right? It's up to, again it's come to here, opposite and hypotenuse is overlapping, but hypotenuse always positive, opposite is negative. So that's why negative R, but opposite and the hypotenuse. When it's come to this distance, it is usually very fast radius. That's why I took R. So R over R is minus R plus R. So answer is minus 1. What is cos 270? It means adjacent divide by opposite. Can you see adjacent? What will happen now? Adjacent, when it's becoming, the angle becoming bigger, the adjacent becoming initially smaller. And when it's come to here 90, adjacent is 0. Then in this green area you can see that adjacent is increasing. Then again adjacent in this blue area, when it's come to blue area, the adjacent is decreasing. Now when it is overlap those two, so adjacent is again 0 and hypotenuse always r. So 0 over r is 0 because hypotenuse we name as radius since it is a circle. Right, now tan 270. Tan 270 mean opposite divided by adjacent. So opposite is almost minus r and adjacent is now 0. So anything divided by 0 is infinity. Now we'll continue further like this. Now again you can say that the opposite is becoming a smaller and the adjacent is becoming larger. Now in this picture you can clearly see that 4 areas, this area, this one and this one. As you know that we can divide the xy plane into 4 parts. So this is first quadrant, we then tell this is second quadrant, this is third quadrant, and this is fourth quadrant. Can you see now this is the first quadrant area. This is xy plane. This is xy plane and this is first quadrant and this is second quadrant, third quadrant and fourth quadrant. Now we have cosine 0 angle value for sine cos tan. Then for 90 we have 0, 90, then 180 we have 180 angle for sine cos ratio. Then 270, for 270 we have sine cos ratio. Now we are increasing this angle and then when it's come to here, this angle size is 360. When it is overlap again, its angle size is 360, which is equal to 0 because it's still the same. It's like if this is your house, this is your door, and you start from here and you go around and you come back to the same position. So when you start, the angle is 0, and when you come back, angle is 360. So the both qualities are same at these places. It means sine 0 and sine 360 should have same uh, values. So then cos 360 should have same values, and tan 360 should have same values. Now what is the summary here? And summary is, so this is triangle, and this is alpha, and this is adjacent, opposite, hypotenuse when you come and stand up here by looking at this direction. Now we know this is first quadrant, second quadrant, third quadrant, fourth quadrant. So what is the positivity and negativity? So sign. What is sign mean? In first quadrant. Okay, we'll draw this one. This is alpha. Uh, this is A, B, C. Sign mean opposite. Opposite divided by adjacent. Hypotenuse. Sign alpha. Cos alpha mean adjacent divided by hypotenuse. Tan mean opposite divided by adjacent. Right? When you consider this triangle, so this is hypotenuse, and this is opposite, and this is hypotenuse, and this is adjacent. So this is opposite is positive value because this is y, and adjacent also positive. So positive divided by positive. In first quadrant, opposite divided by adjacent mean positive divided by positive. So sign is positive. Sign. Then let's look at cos. Cos mean what? Adjacent divided by hypotenuse. We know this direction x axis positive. 0, 1, 2, 3. This is negative. So this is positive. So positive divided by hypotenuse, radius always positive. Positive divided by positive, positive. Cos ratio also positive. How about tan? Tan mean opposite divided by adjacent. But this is also positive. This is also positive. So tan also positive. Now let's go to second quadrant. I will increase this angle up to here. Now you can see that sine mean opposite divided by adjacent. Now this is the opposite. So opposite is positive because above the x-axis, and this is the radius, always positive. So then positive divided by positive. So sine is positive divided by positive is positive. Now let's look at cos. Cos mean adjacent. Now this adjacent in it here, this is the distance. Adjacent divided by hypotenuse. So adjacent become negative. Negative side of uh, the x-axis. So adjacent is negative. It is negative, and this is hypotenuse is positive, which is radius, and negative divided by positive answer is negative. Then tan. Tan mean uh, opposite divided by adjacent. Opposite is positive, and opposite. Here adjacent, here adjacent is negative now. Then positive divided by negative is negative. Now in first quadrant all positive, but in the second quadrant only sign positive, other cos tan negative. Now we'll expand this angle further. This alpha, now this is bigger alpha. So I'll bring it to somewhere here. Now it is sine mean opposite divided by hypotenuse. Right? Opposite. Can you see now this opposite is negative? So this opposite is negative because it is below the x-axis. Radius always positive. Negative divided by positive is negative. So sine is negative. Let's check cos. So this is cos mean adjacent divided by hypotenuse. This is adjacent, and this is adjacent. You can see this length is in negative. So then negative divided by again positive. So negative divided by positive is negative. Now tan. When you look at tan mean opposite divided by adjacent. Opposite negative, and the adjacent also negative. Negative divided by negative positive. It means in the third quadrant sine ratio is negative, cos negative, and tan positive. Now we'll extend it further. I'm going to extend it up to here. Let's say some here. No, we'll go with this one. Sine mean opposite divided by hypotenuse. Okay? This is opposite, and this is opposite again. This is negative again. Now hypotenuse is the radius, always positive. So negative divided by positive is in here, sine is negative. Now let's look at cos. Cos means adjacent divided by hypotenuse. So this is adjacent, this is adjacent, this is adjacent, and this is again adjacent. In here, this is in x positive side, so that is positive. And adjacent, the radius always positive. So positive divided by positive, positive. Now tan ratio mean opposite divided by adjacent. So opposite value also negative. So opposite, yes, value negative, and adjacent value positive. Opposite value negative, adjacent value positive. So tan is going to be negative. You can see this is all positive. This is sine only positive. This is tan only positive. This is cos only positive. Now you can remember this one like this. So in first quadrant, all positives we are keeping in terms of positives. In the second quadrant, only sign positive, others negative. On the third quadrant, tan positive, and on the fourth quadrant, cos positive. So sometimes there are two ways of remembering this one. If we start here, that is A, all St. Thomas College. See, or St. Thomas College. That is one way. Or if you starting from here, C A S T, cast diagram. Right? If you start from here, cast it means positive, all positive, sign positive, tan positive. It means others negative. Or if you start from here, all St. Thomas College. Now, what did we learn? Did we learn about the circles? No. We only learn, right, what is happened to the ratio, right? Sine, cos, tan, opposite divide by hypotenuse, adjacent divide by other. What will happen? This alpha increasing. What will happen to those ratios? So this is the summary. In other way, if I ask, I'll take 135, uh, right? Sine 135, positive or negative? So 135 in second quadrant. Second quadrant sine is positive. Sine positive. In a second quadrant cos negative. In a second quadrant tan negative. If I tell angle 200, right? What is sine 200? Positive or negative? So 200 mean it is in third quadrant, right? We'll measure. It is in third quadrant where this hypotenuse lies. Hypotenuse in here, or the radius in terms of circles, or hypotenuse. So this is 200. So then this hypotenuse lies in this third quadrant. Then sine 200 is in here, tan only positive, then sine is negative. Cos 200 is negative, only positive tan. Tan 200 is negative. If I said 300 angle, it means where's this hypotenuse lies? So 90, 270, another 30. This is the hypotenuse or the radius. So this is 300 angle. This is 300. So what do you know about sine? Sine 300, positive or negative? Cos 300, positive or negative? Tan 300, positive or negative? Sine 300. We know that in this fourth quadrant only positive is cos. It means sine negative, cos positive, tan negative. Another thing is we have, when we measure the angles, if we measure like this, in this way, or anti-clockwise, always we write as positive angle, positive 200 or just 200. But we can measure from clockwise. In that case, we are leaving as negative. So this is whole 200 and this is minus 160. This is your house, right? This is your door. You want to come to this point, this place, right? You can start from here, you can come here, or you can come this way, right? If you come this way, we are telling it positive, anti-clockwise. If you come this way, we are writing angle as a negative, but the location, the hypotenuse location is still same. We can express as positive or negative. If I ask you to do negative 70, so it means you draw, then you are starting from here and you are coming clockwise. For you 10, 20, likewise, you lies the hypotenuse here, and this is 70, and for this direction it's minus. Or about the same hypotenuse you can explain from this way. You starting from here and you are finishing from here. So then this is angle is 70. 360 minus 70 is 290. Right? So this angle is 270. So this hypotenuse is still the same place. So you can come positively or you can come negative. So what is the use of this one? I want to find sine 970. This is same as sine 290. Sine 290. Both same. Finally, now you can see that there are some angles I jot down. Now, if I ask you to draw, now you know to which direction you need to start. You know this is positive. It means you have to start from clockwise. You have to go, sorry, anti-clockwise. This is negative. Then you have to go clockwise. This is positive. So you have to start uh, anti-clockwise. This is negative. Then you have to start going uh, anti-clockwise. So when you look at the symbol, you know which direction you are going to take. Which which side you are going to take. 30 mean you know size. When you look at 30, it is in. So you have to place hypotenuse in here. So that is 30. 110 mean more than 90 but less than 180. So it is somewhere here. If I place the hypotenuse, so this is 110. This direction, this is positive. So 270, about 275. So this is 90, 180, 270, 275, 275 positive. Likewise 200. So start in 90, 180 and somewhere here minus 200. And assume this is your house and you are starting here and you start from here and you are going like this and you are following different geographical variations and you come back to front, then you go in again, but still you are following the same geographical things and same pictures, same thing. So there is no value for second one, just the distance. It will just add the distance, but it is the same quality. For example, if you select this point, either you go and check this point of the qualities or you go one more round and come back again and check the quality. Still the quality is going to be same. Likewise, this is 30 and you go one, starting from here, you go one more round. Now 30 plus 360 you, right. So this is 390. So 30 and 390 has the same qualities and you go one more round, which is another 360. So this is 750, right? So it's still the same qualities. It means if you look at sine 30, that value is same as sine 390. This is same as sine 750. Likewise, you can add So you can find the infinite number of terms, but it has the same quality, same characteristics. It means 30 also in first quadrant, 390 also in first quadrant, 750 also in first quadrant, 30 also positive, 390 also positive sign value, 705 sign value. If you, what is the answer for this one? Half. How do you use this knowledge? If I ask you to find sine 750, so you want to take 360 out. 750, 360 out. This circle's useless. It's not nice to say, but it gives the same qualities, which is this is equal to 390. Instead of you finding 750, 390. Then when you look at, you can see this is still more than 360. Then take another 360 out. 390 minus 360, which is 30. Then sine 30. So if I ask you to find sine 750, you are taking 360s out and you are checking sine 30 instead of sine 750. If you draw a graph, sine graph, still you can find the sine 30, then the same values, those are equal. This is same as cos 30 equal, cos 390 equal, cos 750. Tan also same, tan 30 equal, tan 390 equal, tan 750. If I ask you to find tan 750, take 360 south, and if you find tan 30, so that is the answer for tan 750. And check from the calculator, write tan 30 and check the tan 390 value and tan 750